Welcome to Learn Commerce PU online classes. Don't forget to like our video and subscribe our YouTube channel for all the updates.
Welcome to our first PU Computer Science online classes. In last class, we know that some information from data representation chapter, maybe the number system, maybe the conversion or maybe the base value of decimal number system as well as the binary number system. The decimal number system base is 10. Correct here, and the binary number system base value or radix value is 2. The values are 0 and 1. Now in today's class we are going to start the next third positional number system type. The third positional number system type is the octal number system. Now let's the meaning of the octal number system. As we know that our binary number system or the representation generates long sequences of ones and zeros. When you are going to think about the binary number system, we'll get many zeros and many ones. One example, in last class only we used the value for the binary number 11011. Fractional 101, correct? No, many ones are there, many zeros are there here. So we can say the representation, binary number system representation generates long sequences of ones and zeros while representing a large decimal numbers. To overcome this problem, the other number system like hexadecimal number system and the octal number system is going to use. Clear this point here? The other number system, that means because of some more long sequence of zeros and ones here, because of this reason, to overcome from this problem, the other number system like octal number system and hexadecimal number system is used, because we know that which can effectively perform long strings of decimal number or long strings of binary numbers. Correct, no here? So we can say that the octal number system has 8 digits. Totally how many digits are there? Totally it contains 8 digits here. The digits value going to start from 0 to 7. Okay here? So an octal number system has total 8 digits. The digits going to start from 0 to 7 here. So the base value or the radix value of an octal number system, that is 8 only here, and the positional value are expressed in power of 8. Clear this one? Okay. Now this is about our octal number system. So now here also I want to use one example for the octal number system. So consider an octal number. The number is 234.56 base of 8. Okay. So this is the number I want to use in our octal number system. The number is the 234.50 base of 8 here. So which can be represented as we know that here before the, that means this one is called as the positive positional values here, and here we are using the negative positional value. So that means here before the fractional, correct? No, here before the fractional we are using the first one is the units value, the second value is the 10 value. So 8 to the power of 1 here, and later next one 8 to the power of 2, correct? No, so unit, that is called as the 8 to the power of 0, here tens, 8 to the power of 1, and hundreds, that is 8 to the power of 2, and after the fractional we are using 8 minus 1 and later 8 minus 2, correct? No, 8 minus 2. So which can be represented as here 2 into 8 to the power of 2. Clear? 2 into 8 to the power of 2 plus 3 into 8 to the power of 1 plus 4 into 8 to the power of 0 plus 5 into 8 to the power of 1 plus finally 6 into 8 to the power of 2. Correct? No, here 8 to the power of 2. Now let's how we used in our table. So we can say that following table shows the weightage of the positional value of an octal number. Correct? No? So as we know that because the digits value, what's the digits value I have taken? The digits value is the 234.56 ಓಕೆ 234 ಡಿಜಿಟ್ ವ್ಯಾಲ್ಯೂವನ್ನು 3 ಪಾರ್ಟ್ ಆಗಿ ಯೂಸ್ ಮಾಡಿದ್ದೇನೆ. ಮಿಡ್ಲ್ ಒನ್ ನಾವು ಐ ಆಮ್ ಗೋಯಿಂಗ್ ಟು ಯೂಸ್ ಹಿಯರ್ ದಿ ಡಿಜಿಟ್ ವ್ಯಾಲ್ಯೂ ಇಸ್ ದಿ 234.50 and weight value as we know that show the weightage of the positional value, correct no? So we know that the first one before the fractional, that means the positive positional value 8 to the power of 0, 8 to the power of 1 here, okay, and 8 to the power of 2, and after the fractional the negative positional value 8 minus 1, 8 minus 2, correct no? 8 minus 2 here, and later now what about this value, how we got this value, as we know that 8 to the power of 2, that means here we can say 8 into 8, okay, 8 into 8 when you are going to multiply the value will get as the 64. So e value hege bantu 8 into 8, clear this one, 8 into 8 the value will get as the 64. 2 times we need to make the multiplication of 8 here, 8 value, and later next one as we know that there is no multiplication here, just only the value will get into 8 into 1, the value will get as the 8, clear this one, 8 into 1 one time only, as we know that the note, most important note, 8 to the power of 0 always the value is 1, clear this one, always the value is 1 here, and later 8 minus 1 e value hege bantu 0.125, that means I used the value 1 by 8, clear this one, the 1 by 8, 8 minus 1, 10 minus 1, 1 by 10 hege ನಾವು ಯೂಸ್ ಮಾಡಿದ್ದೇವೆ. ಅದೇ ಆಕ್ಟಲ್ ನಂಬರ್ ಅಲ್ಲಿ ನಮಗೆ ಗೊತ್ತಿದೆ ಪೊಸಿಷನಲ್ ವ್ಯಾಲ್ಯೂ 8, ಕ್ಲಿಯರ್ ನೋ, ಪೊಸಿಷನಲ್ value, radix value, base value all are same, are equal to 8 here. So 1 by 8 the value will get as the 0.125, okay, and later next one 8 minus 2, that means here 8 into 8, 8 into 8, that means we need to do it 100, clear this one, 100, that means here we can say that 8 by 64, clear this one, 8 by 64 ನೀವು ಯೂಸ್ ಮಾಡುವಾಗ 0.015625, ಅದರ ನಂತರ 2 into 64 plus 3 into 8 plus 4 into 1 plus 5 into 0.125 plus 6 into 0.015625, later words we will get the value 234.56, clear this one here. So this is the representation by using the table of an octal, clear this one. So artha aitalla octal table. Now after completing the octal here, as we know that no any confusion, as we know that decimal number, base value, position value 10, okay, the number ellinda ellivarige 0 to 9, binary value the base value is 2, the numbers are 0 and 1, octal value the base value is the 10, the numbers are the 0 to 7. Now later the fourth type name is called as the hexadecimal number system, okay, the hexadecimal number system. So we know that the hexadecimal number system has totally 16 digits. So totally ಎಷ್ಟು digit ಇದೆ ಇದರಲ್ಲಿ, totally 16 digits, 16, okay, 16 digits here. So it contains the numbers, or it has the numbers from 0 to 9, okay, the 0 to 9, and also A, B, C, D, E, and finally F. So when you are going to count 0 to 9, that is equal to 10, ಇಲ್ಲಿ ನಮಗೆ 10 ಅಂತ ಸಿಗ್ತದೆ, correct no, 10, 11, 12, 13, 14, 15, 16. So total it contains the 16 digits, 0 to 9, A, B, C, D, E, and F, maybe the capital or small A, B, C, D, or maybe the capital A, B, C, D till F here. So total it contains the value 16 digits here. So the base value is 16, the radix value is 16, so the positional value also expressed in power of 16 only, okay, in our hexadecimal number system. So we can say that the digits that is the A, B, C, D, E, and F have decimal equivalent to A value is equal to 10, B value is equal to 11, C value is equal to 12, D is equal to 13, E value is equal to 14, and F value is equal to 15. You should remember it. It started from 0 to 9, correct no kya, 0 to 9 totally will get the value 10, but also we can say that the A value is started from the 10 only, ಅರ್ಥ ಆಯ್ತಾ ಎಲ್ಲರಿಗೆ. ಸೊ ಟೋಟಲ್ ನೀವು ತಗೊಳ್ಳುವಾಗ 16 ನಮಗೆ ಸಿಗ್ತದೆ, ಹೇಗೆ ಸಿಗ್ತದೆ, 0 ಇಂದ 9 ನೀವು ಕೌಂಟ್ ಮಾಡುವಾಗ 10 ನಮಗೆ ಅಲ್ಲಿ ಸಿಗ್ತದೆ, 11, 12, 13, 14, 15, 16, but how they added the value, So we can say that the digit A, B, C, D, E and F have decimal equivalent to A is equal to 10, B is equal to 11, C is equal to 12, D 13, E 14 and F 15 respectively. Now let's like that only how we added one example, the table example in our decimal binary octal number system. Like that only here also I want to use one table for our hexadecimal number system. So consider the hexadecimal number system. The number system is the 5AF fractional D base of 16. ಈ ನಂಬರ್ representation ನಾನು ಮಾಡ್ತಾ ಇದ್ದೇನೆ ಎಕ್ಸಾಂಪಲ್ ಆಗಿ hexadecimal ಗೆ. So the number 5AF and fractional D, as we know that A value that is equal to 10, F value that is equal to 15, D value is equal to 13. Correct na kya? D value is equal to 13. Now let's about the table. So digit, as we know that 5AF D, okay kya? And whatever I return, this is just only the digit equivalent value, okay? The decimal, the digit or the decimal equivalent value to the letter A. A value is equal to 10, F value is equal to 15, D value is equal to 13, okay? So this is the number suitable equivalent letter kya? And we know that means F position value 0, 16 to the power of 0, A 16 to the power of 1 and 5 16 to the power of 2 here and D 16 to the power of 1. ಯಾಕೆಂತ ಹೇಳಿದ್ರೆ ಫ್ರಾಕ್ಷನ್ ನಂತರ ಫ್ರಾಕ್ಷನ್ ಪಾಯಿಂಟಿನ ಮೊದಲು ಪಾಸಿಟಿವ್, ಫ್ರಾಕ್ಷನಲ್ ಪಾಯಿಂಟಿನ ನಂತರ ನೆಗೆಟಿವ್. ಕರೆಕ್ಟ್ ನೋ? So 16 to the power of 0, 1 and 2 and 16 minus 1. Okay, the 16 minus 1 here. So later next one. Now let's the table. First of all, we know that F positional value 16 to the power of 0. Correct no? 5AF D. Now I am using the weight value 16 to the power of 0, 16 to the power of 1 here, like that one by one going to make the increment 16 to the power of 2. Ade fractional point nantara negative use ಆಗ್ತದೆ 16 minus 1. ಅರ್ಥ ಆಯ್ತಾ? 16 minus 1. Now how we got this value? We already know that means 16 to the power of 2. 16 into 16. Okay, 16 into 16. The value will get as the 256. ಅರ್ಥ ಆಯ್ತಾ ಎಲ್ಲರಿಗೆ? 16 into 16, 16 to the power of 2, 16 to the power of 1, that means one time only. So the value will get as the 16 only one time. 16 into 1, the value is 16. So like that only here also how we used 8 to the power of 1, the value is 8 one time only. So like that only 16 to the power of 1 one time only, but 16 to the power of 0, always remember it, the value will get as the 1 only. Correct here? And later 16 minus 1, that is equal to 1 by 16. Okay, 1 by 16, the value 1 by 16 in this case here, maybe 16 to the 16 minus 2, that means 1 by 256. Okay, 1 by 256, like that the value will get as here. Maybe if any more value, if more negative value 16 minus 2 ಅಂತ ಹೇಳಿದ್ರೆ 1 by 256 ಆಗ್ತದೆ value, but 16 minus 1, the value will get as the 1 by 16 value ಎಷ್ಟು ಬರ್ತದೆ? 1 by 16, the value is the 0.0625. Okay kya? And laterwards we know that how we need to make the representation, that means such a representation we can do it. The representation is the 5 into 16 to the power of 2, A into 16 to the power of 1, F into 16 to the power of 0, D into 16 to the power of 1, and as we know that 5 into 256 plus A value that is equal to 10, 10 into 16 plus F value is the 15, 15 into 1 plus D value is 13 into 1 by 16, the value will get as the 0.0625. Okay, and laterwards you have to make the addition. 5 into 256, you will get sum of the value, plus 10 into 16, you will get sum of the value after the multiplication, plus 15 into 1, the value will get 15, plus 13 into 0.0625. So lastly we'll get the final value. So clear this point here. After make the addition, after make the multiplication, and later was you have to make the addition of this value, you will get the correct value of this example. Clear this one kya artha aita ellarige? So this is called as the some example of hexadecimal number system. Now after completing the hexadecimal number system, now let's some important number system conversion. So idu artha aitalla ellarige hege anta, yakandre 5 into 256 ಇಲ್ಲಿ value ಬರ್ತದೆ, correct? No, 5 into 256 here. So later next one 10 into 16 the value will get into 15 into 1 the value 13 into 0.0625. later was you have to make the addition of this value, and lastly it is called as the final answer. So clear this point here. So this is about our hexadecimal number system. Now after that, after completing the hexadecimal number system, the next thing about our the number system conversion. Now very important thing we are going to complete. So all those conversion will get for 5 marks. Clear this point? It's a 5 marks question here. So very important conversion. So you have to listen it properly. How in which manner I am going to do the conversion from one number system to the another number system. Okay. So side point gottagidella, number system conversion, that means conversion of all types. Now first conversion I want to select, the first conversion is the decimal to binary conversion. Okay. The decimal to the binary conversion. So decimal to the binary conversion ಅಲ್ಲಿ ಕೆಲವೊಂದು steps ಇದೆ. Okay, some of the steps are there in decimal to the binary conversion. Now let's, what are the steps are there in our decimal to the binary conversion? Okay, so the first step in our decimal to binary conversion, first of all divide the given decimal number by 2. Okay, so first of all you have to divide such number by 2 here. So divide whatever the number you will get in question, such number need to divide by 2. Okay, and later next one, note the quotient and the remainder. Clear this one here. Note the quotient and the remainder. So maybe quotient and remainder you will get when you are going to divide by 2 such number, you will get some of the quotient and the remainder. Later words I will tell which is called as the quotient and the remainder. Step 3, repeat step 1 and step 2. Okay, again and again you have to repeat the step 1 and step 2 until quotient becomes 0. Clear this one here? Until the quotient becomes 0. Clear this point here? ಎಲ್ಲಿಯವರೆಗೆ ನಾವು ಕಂಟಿನ್ಯೂಷನ್ ಮಾಡ್ತಾ ಹೋಗಬೇಕು, ಡಿವೈಡ್ ಮಾಡ್ತಾ ಹೋಗಬೇಕು, ಎಲ್ಲಿಯವರೆಗೆ ಕ್ವೋಷಂಟ್ ಮತ್ತೆ ರಿಮೈಂಡರ್ ಆಗಿ ಅಕ್ಸೆಪ್ಟ್ ಮಾಡ್ತಾ ಇರಬೇಕು ಅಂಟಿಲ್ ದಿ ಕ್ವೋಷಂಟ್ ಬಿಕಮ್ಸ್ ದಿ 0. ಓಕೆ ಕ್ಯಾ? ಅಂಡ್ ಲೇಟರ್ ನೆಕ್ಸ್ಟ್ ಒನ್, ದಿ first remainder will be the our LSB. Okay, and the last remainder is called as the MSB. Okay, this one is the first remainder and this one is the last remainder. Clear this point here? The first remainder will be the LSB, least significant bit here, and the last remainder is the MSB, most significant bit here. So finally the equivalent binary number is then returned from, we are going to write from MSB to LSB. Clear this one here? It is going to write from MSB to LSB, that is called as the left to right. Clear this point here? That is called as the left to right. Did you remember while going to take the example 1000, I said this one is the MSB and this one is called as the LSB. Correct? No, LSB, and this is called as the right hand. The right hand in this case here. So here this one is the left hand. Correct? No, and this one is called as the right hand side. Right hand side here. So we can say that the leftmost bit, rightmost bit, the leftmost bit is equal to MSB, rightmost bit is equal to LSB. Okay, so after getting the answer, such answer need to write that is equivalent from MSB to the LSB, that is called as the left to right. Okay, now let's, all those explanation we know that by using all those steps we are going to complete one example. Now let's the question. The question is the decimal number or consider a decimal number 53 base of 10, okay, which can be represented in binary. Now which type of conversion we are going to do? The conversion decimal ಇಂದ ಬೈನರಿಗೆ ಆಗ್ತಾ ಇದೆ. ಕನ್ವರ್ಷನ್ ಈಗ ನಾವು ಒಂದು ಕನ್ವರ್ಟ್ ಮಾಡ್ತಾ ಇದ್ದೇವೆ ನಂಬರ್ ಅನ್ನು ಡೆಸಿಮಲ್ ಇಂದ ಬೈನರಿಗೆ. ಸೊ ಡೆಸಿಮಲ್ ಇಂದ ಬೈನರಿಗೆ ಕನ್ವರ್ಟ್ ಮಾಡುವಾಗ ಈ ಎಲ್ಲ ಸ್ಟೆಪ್ಸ್ ನಮಗೆ ಬೇಕಾಗ್ತದೆ. ಓಕೆ, ಸೊ ಫಸ್ಟ್ ಸ್ಟೆಪ್, ನಾವು ಐ ಆಮ್ ಗೋಯಿಂಗ್ ಟು ಟೇಕ್ ದಿ number 53 and such one going to divide by 2. Okay, again and again I am going to divide by 2. When you are going to multiply, when you are going to divide 53 by 2, it will go 26. Clear this point here? 2s are 52. Clear this point? 26 into 2 ಮಾಡುವಾಗ 52 ಬರ್ತದೆ ನಿಮಗೆ. Now remainder is the 1. Now this is called as the quotient, okay, and this one is called as the remainder. ಅರ್ಥ ಆಯ್ತಾ ಎಲ್ಲರಿಗೆ? Remainder, this is the quotient, this is the remainder. So divide the given decimal number by 2, okay, one by one, and note the quotient and the remainder. So divide it. Now quotient, remainder, again it will go 2 13s are 26. 2 13s are 26. The remainder, no any remainder, every value, everything will go divide by 2, 26. So 2 13s are 26. Remainder value is 0. Correct? No? Okay. Now puna 13 ಅನ್ನು divide ಮಾಡಿ. 2 6 are 12. That means remainder value is 1. Okay? 2 3s are 6. No any remainder value. Clear this point here? 2 1s are 2. Now actual value is 3, so 1 is the remainder. 2 1s are 2. Now remainder is 1, but till where we need to divide? So note the quotient and remainder, again and again divide it, and you have to divide it until quotient becomes 0. Have to divide until the quotient becomes 0. Now whether one value will go by whether one value it will go here when you are going to divide by 2? No. Correct? No? So that means 0 we need to write, and this one we need to write it here. Clear this point here? 1, that means it not will go here, so 0, and this one value will write it here. So that means until the quotient becomes 0 here. Clear this point? You have to divide again and again and get the quotient and the remainder until the quotient becomes 0, and the first remainder is called as the LSB. Okay, the first remainder, one is there, no, is called as the LSB, and the last remainder is called as the MSB. Clear this point here? Called as the MSB. So the equivalent binary number is then written from how to get the value. That means I am going to start from this value. This 0 I am not going to take. Okay, here it is called as the quotient. Just only the remainder value I am going to take, because I already said in note. That means the first remainder. So 26 13 6 3 1 0 all comes under quotient. 1 0 1 0 1 1 all comes under remainder. Clear this one? So the equivalent binary number is then written from here MSB to LSB. As we know that the first remainder is called as the LSB and last one is called as the MSB. Going to write from MSB to LSB. So 1 1, okay, 0 1 0 1, but need to convert decimal to binary, so need to write the base of 2. Clear this point here? Need to write the base of 2. So this is the answer of 53, decimal number 53 base of 10. Okay, we converted to the binary, so answer 110101. Now let's one more number we are going to divide. So in this number, okay, so here first of all number 227, is it will going to divide? No. So 2 13s are 26, 1 is the remainder. 2, correct no here? So we can say that 2 13s are 26, 1 is the remainder, again 2. Okay, 2 how much the 13? 2 6 are 12. 1 is the remainder. 2. 2 3s are 6. That means no any remainder. 0. Clear this point here? ಅರ್ಥ ಆಗ್ತಾ ಇದೆಯಾ? 27 ಅನ್ನು ನಾನು ಡಿವೈಡ್ ಮಾಡಿದೆ 2 ಇಂದ. 2 13s are 26. 1 is the remainder. 2 6 are 12. 1 is the remainder. Total 13 value ಇದೆ. 12 ಮಾತ್ರ ಡಿವೈಡ್ ಆಗ್ತಾ ಇದೆ. ಕರೆಕ್ಟ್ ನೋ ಮಲ್ಟಿಪ್ಲೈ. 2 6 are 12. 1 is the remainder. 2 3s are 6 here. 0 is the remainder. And 2 2s are 2 1s are 2 1s are 2. 1 is the remainder. 2 1s are 2. 1 is the remainder. And 2 whether 1 is go? No. So 0 and this one we need to take it here. So clear this point here. And later next one. The first remainder, this is called as the remainder. Clear this point here. This is called as the remainder in this case here. Remainder. So the first remainder LSB and last remainder called as the MSB. That means the equivalent binary number is then written from our 11011 base of 2. Okay. So this is the answer. So how I started? That means the equivalent binary number I want to write as the left to right. Okay. Kya? So MSB to LSB. So 11011. So this is the answer of the decimal number 26. So clear this one. So this is our first number conversion. The conversion from decimal to binary. Step ಗೊತ್ತಾಗಿದೆ ಅಲ್ಲ? That means any number divide by 2, note quotient and the remainder. And later next one we need to repeat step 1, step 2 until quotient becomes zeros. And the first call as the LSB, the last remainder call as the MSB here. And how we are going to write MSB to the LSB down to up. So this is the answer for the decimal to binary conversion. Thank you for watching this video.
Don't forget to like our video and subscribe our YouTube channel for all the updates.